Okay, this is part 3 of how I teach using digits, Realize. And so if we go to digits and I pick a program, I'm going to go to digits 8 and I'm going to choose geometry. And let's go with Pythagorean theorem. And so this is a project, and then we have a readiness lesson. These would then be regular lessons. And so I'm going to just pick lesson 2, the Pythagorean theorem. And you will notice that every lesson typically has a launch. It usually has a key concept somewhere in the lesson. And then it has 3 parts. Each part tends to get a little bit more abstract. And then a closing check. There's also homework. But the most important part is these teacher resources. And if you don't see them, you have to click on Show Teacher Resources. And here you can have an editable lesson plan. It's just a basic lesson plan. You can print the homework. You also could print the student companion. But most important is down here the teacher guide. The teacher guide is usually a 7 or 8 page PDF, and this PDF contains lots of information. The first page just is the basics of the lesson, and what it does is it breaks up the lesson and gives you questions to ask before, during, and after any part of the lesson. So here before the launch, here it talks about the key concept. Part 1, what to do during the intro, before you solve the problem, and what Jay, the narrator, is going to say, and so on and so forth. But once you get past that first page, and at least read the first page, then you really get into a lot of meat. Lesson objectives, a focus question, the math background needed, again, the objective of the launch, the author's intent of the launch, the instructional design of the launch. Here are the questions before, during, and after the launch with some sample answers. Goes a little more deep. Solution notes, connections to learning, teaching tips, on and on. ELL support. There's just a bunch of stuff here. Beginning, intermediate, advanced things. That is where a lot of people mess up when they're teaching digits. They just use the slides. And if you do that, you're really missing a lot of the cool, rich, deep content and having great discussions. So when you start, typically I start with the launch. And the launch is sometimes an animation, sometimes it isn't. This is in their student companion book. And it's just asking, what do you notice about the relationship of the squares in group 1 and the relationship of the squares in group 2? Here's where I would give them some time. 5 minutes maybe, where they work, and they work on their student companion in their workbooks here. This is what it looks like to them. And I make them write. And so it says describe a possible relationship. I make them use full sentences, capitalization, and I walk around the room. While I'm walking around, I try to see how students are solving it. Because after the 5 minutes, I'm going to call on different students to come up and explain how they did it. And what I'm looking for is different ways of how they attempted the problem and how they solved it. Typically, the launch is something they haven't seen before but have enough information to solve. This is where your mathematical practices come in. Different ways of attacking problems. The next slide gives the focus question. A lot of times I'll ask them if they know the answer. This is what they should be able to answer by the end of the lesson. After the launch, in this one, is the key concept. Again, sometimes the key concepts are animations, movies. Sometimes they're just words or activities. This one is a movie. I'm just going to play a little part.
In a right triangle, the 2 shortest sides are legs. The longest side, which is opposite the right angle, is the hypotenuse.
Now notice that the movie stops right here where this arrow is, and that's because that's a place to natural break in the movie where you can stop and you can explain what are the legs, where the hypotenuse. Feel free to stop the animations or movies within their playing time so that you can explain. So after the key concept is part 1. Part 1 in this one has an introduction. It just says you can use a Pythagorean theorem to find the lengths and gives them the formula. It was in the key concept. Then is the example. Now the first part of any example, so part 1, the first slide, I do together as a class. Here is one where I would have the students come to the board, I'd draw names, they would come up, they would drag their answers here. Once they have them in place, we could check our answers, hit check, and it says that's not quite right. What did we do wrong? And so here I'd say, okay, let's try that again. And so we know the correct answer there was 13. And when you get it correct, he does a little bobblehead. There you go. This is a J says. J is a narrator.
When the three side lengths A, B, and C satisfy the equation a squared plus b squared equals c squared and are non-zero whole numbers, they have a special name. They are called Pythagorean triples.
So here's where it talks about Pythagorean triples. That's a whole nother discussion that you can have. What other Pythagorean triples can you come up with? And things like that. After we've done one together and had discussion, then is the got it. The got it's are where I have them, the students, work on it at their desk. Again, it's in the Student Companion, in the national version of the Student Companion, and I walk around, make sure they have it. We can turn it into multiple choice if we want, and we can show the correct answer. You don't have to use multiple choice. The solution, again, is always here, down here where the solution button is. After part 1, we go to part 2.
Okay, Bobby, come on, you can do it.
Little animation.
He's stealing! Throw to second! Throw to second! Psych!
These animations are in
Whose
here.
idea was it to put second base so far away?
Animations are in here so that it gets the students' attention. Even if they groan, they're at least paying attention. So again, this is one that I would work on together as a class. I wouldn't do it for them. I would ask them, what do you know? How should we approach this? We'd work on it together. There's another Jay says, I'm not going to play it for issue of time, but he talks about baseball. Then again, there's a got it. Okay, this is to the nearest tenth. Can you find the length of the hypotenuse? Then we go to part 3. Part 3 is yet a little bit more complicated. This one, notice the words in blue, pyramid and slant height. If you click on those, the vocabulary word will come up. So I clicked on slant height, so there's a definition. And so you can talk about this. And now, to the nearest hundredth, what is the slant height of the Great Pyramid? A little more complicated. Again, work on this as a class. The got it, that's what they do on their own on paper. Walk around, make sure they understand. Once you're done with the 3 parts, then there is the close and check. The close and check on the screen just asks that focus question again, which you can have a discussion. But in the student's companion book, there is a page. It has excellent questions. It has the focus question at the top. And then it has questions on the left-hand side, kind of like what you did in class. Questions on the right-hand side are a little bit deeper where they have to do a little more writing. If you have time, do all these and discuss them in class as well. Usually that will take up a class period. But if you have more time, feel free to then go to the homeworks. And the homeworks are in order from least complicated to most. And so I tend, if I have time in class, to start with the most complicated one and work our way backwards to see if we can figure this out. And you can make it bigger on your computer so you can see it. So that's how I go through and teach a regular lesson using Digits Realize.